Let's see next example to calculate IDFT of a given sequence using decimation in frequency FFT algorithm. Given sequence is x of k equal to 0 minus 2j, 0 plus 2j. First step, taking complex conjugate of a given sequence, that is x conjugate k equal to 0, 2j, 0 minus 2j. As it is a complex conjugate, we have to just change sign of imaginary term, that is plus j will become minus j and minus j will become plus j. For this example, number of samples capital N equal to 4, that implies n equal to 2 raised to m, that is equal to 2 raised to 2, means number of stages for this example will be 2. For n equal to 4, bit reversal is given as input sample index 0, 1, 2, 3, and after bit reversal it will be 0, 2, 1, 3. Next, for n equal to 4, number of butterflies in each stage equal to 2. Separation in inputs and outputs in case of a DIF is given as 2 raised to m minus m. For stage 1 it will be 2 samples and for stage 2 it will be 1 sample. The number of complex multiplications will be n by 2 log n to the base 2, that is equal to 4, and number of complex additions will be n log n to the base 2, that is equal to 8. Total factor exponents are a function of stage index small m in such a way that k equal to capital N into t divided by 2 raised to m plus m minus 1, where t is ranging from 0 to 2 raised to m minus 1. So for stage 1, value of t will be 0 and 1. For that we will get two total factors, that is k equal to 0 and k equal to 1. That means in case of DIF example, in stage 1 we will require two total factors, omega n0 and omega n1, as value of n is 4, so omega 4 0 and omega 4 1. For stage 2, t equal to 0, that implies k equal to 0, that means for stage 2 we will need single total factor, that is omega 4 0. Calculating values of total factor using definition, omega 4 0 equal to 1 and omega 4 1 equal to minus j. Next, number of sections of butterflies in each stage equal to 2 raised to small m minus 1. For stage 1, number of sections 1, and for stage 2, number of sections 2. Next, exponential repeat factor, that is number of times total factor is to be used. So for stage 1, ERF is 1, and for stage 2, ERF equal to 2. This is IDFT, DIF butterfly diagram, or you can say flow graph. So input is again complex conjugate of input sequence, but as it is a DIF, input will be in a natural order and output will be bit reversed. As this figure shows, there are two stages. Each stage is having two butterflies. First stage is having single section of butterfly and second stage is having two sections of butterflies. In first stage, total factors used are omega 4 0 and omega 4 1. As ERF is 1, these total factors are used only once in stage 1, and in stage 2, total factor used is omega 4 0, and as per our ERF value, ERF is 2, we have to use this total factor omega 4 0 twice. Now next what we have to do, we have to solve this particular flow graph, or we have to calculate values of first input and values of output of first stage and output of second stage. As in these FFT algorithms, output of first stage becomes input for second stage. This is nothing but operation of in plus computation. So for stage 1, S1 of 0 equal to simply addition of two inputs, that is equal to 0, S1 of 1 equal to 0, S1 of 2 equal to subtraction of two inputs multiplied by omega 4 0, that is equal to 2j minus 2j 0, and S1 of 3 equal to subtraction of two inputs multiplied by omega 4 1, that is equal to 4. Now for stage 2, S2 of 0 equal to n into x conjugate 0, that is equal to 0, S2 of 1 equal to n into x conjugate 2. Why 2? Because output of DIF is always bit reversed. So n into x conjugate 2 equal to 0, n into x conjugate 1 equal to 4, and n into x conjugate 3 will be minus 4. But these are values of capital N multiplied by x conjugate of n. But finally we need answer for x of n. So first step, divide these all 4 values by n. So what we will get, x conjugate n equal to 1 by 4 in bracket n into x conjugate, and that is equal to 1 by 4, 0, 4, 0, minus 4, that is equal to 0, 1, 0, minus 1. Now this is x conjugate of n sequence, but we need x of n. To get x of n, what we have to do? We have to take again complex conjugate of x conjugate n. So as per concept of complex conjugate, what we have to do? We have to change sign of imaginary term, but for this sequence there is no imaginary term, therefore x of n will remain as it is, that is x of n equal to 0, 1, 0, minus 1. So this is IDFT of a sequence, that is equal to x of n equal to 0, 1, 0, minus 1. So this is example of calculating IDFT using decimation in frequency FFT algorithm.